Welcome back, chemistry. We're finishing chapter 2 today and ending with scientific notation. We're going to, basically the purpose of scientific notation is to get rid of those non-significant zeros. If I take a look at my first example, 0.00012 millimeters, these zeros are not significant. So I'm just going to get rid of them, right? But in order to do that, I need to make sure that I have something in place, those place values to know. I just can't get rid of them and say 12 millimeters because 12 millimeters does not equal 0.00012 millimeters. So what I'm going to do is I'm going to put the number in scientific notation. And how I do that is I move the decimal place to get rid of those zeros, and then I add a times 10 to the whatever exponent. So those zeros are, they're there, but they're not there. So if I move this decimal place over 1, 2, 3, 4, and I moved it to the right, anytime you move the decimal place over to the right, it's going to be a negative exponent. So my first answer here, I'm going to put down 1.2 times 10 to the negative 4 millimeters. Now, I know Fisher calculators sometimes put the decimal place after the second digit. If you want your answers correct in this class, you will place your digit after the first real digit. Okay, so the first significant digit, that's where that decimal goes, right after it. Okay, not the second, not the third. I don't know why that is a thing now with calculators, but you're going to need to be able to move the decimal place. So if you move it to the right, it's going to be a negative exponent. Okay. Second example here, 65,000 kilometers. These zeros are at the end of a number and they are not significant. So I'm going to get rid of them in a way, kind of hide them by using scientific notation. So if I count 1, 2, 3, 4, I'm going to move it to the left, and that's going to be a positive exponent. So my answer is going to be 6.5 times 10 to the 4 kilometers. So this equals that, and this equals that. Now when you do addition and subtraction, the rules change a little bit. You can only add and subtract exponents if the exponents are the same. So here I have 4.2 times 10 to the 4 kilograms plus 7.9 times 10 to the 3 kilograms. The times to the 4, 10 to the 4 times 10 to the 3, they're not the same. So you need to choose which one you want to manipulate or change so that the exponents are equal. So in this case, I'm going to put both numbers to times 10 to the 4 kilograms. So I'm going to leave this one and I'm going to change this one to 4. And how I do that is I'm going to move it over to the left, because when you move it over to the left, then the exponent increases. It's positive. So if I move it over 1, well, now it's going to be times 10 to the 4. So I'm going to put down 0.79 because I moved that decimal place over to the left, 0.79 times 10 to the 4 kilograms. And now I can just do whatever I'm doing here. I'm doing addition, so I'm going to add these numbers up. Okay, and I'm going to get a value here. Let's see, 4.2 plus 0.79. I get 4.99. 4.99 times 10 to the 4, right? 10 to the 4 kilograms. Now, we discussed sig figs yesterday, and when you do addition, you go until the last common place. Okay, so in this case, it's one place after the decimal. So I have 4.9, and then I got to look at this number and determine if I need to round. And I am going to have to round, so this is not technically my answer. My answer, I'm going to round, is going to be 5.0 times 10 to the 4 kilograms. There we go. That's it. Okay. All right, moving on. Multiplication with scientific notation. What you want to do is you want to multiply the factors. The factors are the numbers in the front of the exponents. And then you add your exponents. So when I set this up, I'm going to multiply 5.23 times 7.1, okay? But then I'm going to add the exponents. So I'm going to go 6 plus a minus 2, as you can see here, 6 plus a minus 2. So 5.23 times 7.1, I get 37.133 times 10 to the, and then 6 plus a negative 2 is 4 millimeters squared, because I'm multiplying millimeters by millimeters, so it's going to be millimeters squared. So just watch out for those units, okay? It's not millimeters. You'd lose half credit if you just had millimeters and not millimeters squared. Okay, so I get this answer. There's a couple things wrong with it. First off, the decimal, this is scientific notation. We want that decimal right after the 3. Okay, so we're going to need to move it like so. And then not only that, then you have to ask yourself, how many sig figs do we want? Well, here I have 3 sig figs, and here I have 2. So you go with the least common, and so we need 2 sig figs. So your answer is going to be 3.7. There's my 2 significant figures. But because I moved the decimal over this way once, instead of being times 10 to the 4, it's going to be times 10 to the 5, 10 to the 5th. And then millimeters squared. Okay. And again, you could punch all of this into your calculator and then, check to make sure that you're actually right. Division. Move my face up here. 5.44 times 10 to the 7 grams divided by 8.2 times 10 to the 4 moles. You'll divide the factors. So you'll divide the front numbers, and then you'll subtract the exponents. So 5.44 minus, get a pen here, or sorry, not minus, divide, yeah. So 5.44 divide by 8.2, and then I'm going to subtract the exponents. Okay, and I get something like, let's see, 5.44 divided by 8.2, so it would be a really small number. 0.6634 times 10, and then there's my 7 minus 4, so I get, when it's all said and done, 6.6 times 10 to the 2. So let me just walk you through that because I kind of skipped. So here, this is incorrect, right? So let's focus on this first, sorry. 7 minus 4, okay, is 3. So I have 0.6634 times 10 to the 3, but the decimal place is in the wrong spot, so I need to move it over. Now, when you move it to the right, you subtract, okay? It gets smaller. I moved it over one spot, so that means instead of being a 3, it's going to be a 2. Okay, and then we're dividing, and I have 2 significant figures versus 3, so my answer has to be in 2, and so that's why it's 6.6 times 10 to the 2 grams per mole. This is a derived unit. The units don't cancel out. You got to keep them. Hopefully this is kind of making sense. Okay, a sample problem dealing with density. Okay, calculate the volume of a sample of aluminum that has a mass of 3.057 kilograms. The density of aluminum is 2.7 grams per centimeters cubed. So density is mass divided by volume. Now, they give us density, okay? They give us mass. However, it's in kilograms. That doesn't work. So you have to convert kilograms to grams. So you start with what you're given, and then you say, okay, I'm in kilograms. So kilograms goes on the bottom, and you want to get to grams, and then you ask yourself how many grams are in a kilogram, and that's 1,000. So 3.057 kilograms times 1,000 is 3,057 grams. So I have 3,057 grams on top over V, okay, or divided by V. So I'm going to solve for volume. Now to get V by itself, you take both sides times V times the volume. So V is like technically over here, right? But I want V by itself, so if I take 3,057 grams divided by the density, which is 2.7, you get this, which equals this. Sorry, lights are going off here. So volume equals 1,132.22. However, sig figs, right? Here I have 3 sig figs, and here I have 4 sig figs, so my answer needs to be in 3. So I set it up like this. But then I'm like, well, scientific notation, that's what this lesson's all about. So I move it over 1, 2, 3. I moved it to the left, so it's going to be positive. So it's 1.13 times 10 to the 3 centimeters cubed, because grams, the unit grams, cancel out. I think it's kind of glitchy here. Okay, cancel out. Wow. Okay, moving on. Final thing I want to talk about are trends. Okay, trends. So this is nothing new either. If a trend is directly proportional, that means that you have these two quantities and you divide it and you always get a constant value. So if one increases, the other is going to increase. If one decreases, the other is going to decrease. And it's going to decrease or increase by the same factor. Your book talks about these equations. I would strongly recommend reading page 59 to 60 in your book. But y over x equals k, and k represents the constant. And when you rearrange the equation, then you get y equals k times x. Now, inversely proportional means that as one goes up, the other one goes down. And it's usually a product equation set up. So here, x times y equals k. So if x increases, then y has to decrease because they're multiplying in order to get the same value k. So if you double the speed, then time's going to be decreased by half. When we get to gas laws, you'll see a lot of directly proportional and inversely proportional gas laws. And I think that does it for notes. Yes. Okay, so you have a book assignment, a 2.3 book worksheet that is due tomorrow. Your review guide is also due tomorrow. When you come back from break, we'll quickly review and then take a test the next day. So that does it for chapter 2.